Let's continue adding and subtracting fractions, and look, I'm just increasing the complexity and the difficulty level. This video segment might include the next 3 problems. So first of all, again, remember you got to factor the denominator. So here I need a 2 times an x minus 1. This one can't be factored. And this one is x plus 1 times x minus 1. So my LCD is each factor that occurs the greatest number of times. So a 2 occurs once, and x plus 1 occurs once in this denominator and that one, and an x minus 1 occurs once in this denominator and that one. So this first fraction right here has the 2 and the x minus 1, but it's missing the x plus 1. So I'm going to take the shortcut and just show that I have to multiply the 3 times the x plus 1, and that will be a 3x plus 3. Please know now that that fraction has the full LCD because that fraction now has the x plus 1 as well. See this fraction right here, the 5? It only has the x plus 1. So it needs the 2 and the x minus 1 in order to be complete. So the 5 times 2 will be a 10, and the 10 times x will be a 10x, and the 10 times the minus 1 will be a minus 10, and now it has the whole LCD. Please, I'm cheating a little bit. I'm not showing that I'm multiplying top and bottom by the 2 times the x minus 1. But down here I am showing that this denominator now has the 2 and it has the x minus 1 in it. This denominator had both binomials. It does not have the 2 though, so it has to be multiplied top and bottom by the 2. So this numerator will become a 2x, and it's over that common denominator. This one happens to be a subtraction sign, so be careful. That just means though that this minus 2x will be plus a negative 2x. So now let's go ahead and grab our like terms. So the 3x and the 10x is a 13x. You take away 2x and you'll have 11x. This 3 take away 10 is a minus 7, and that's my numerator to this problem that has a common denominator of 2 times x minus 1 times x plus 1. I'm all done. Let's go over here. Ooh, yikes. I almost feel like this one might be simpler, but it's probably going to reduce. Let's go to number 12 first. The reason I did that is because this denominator has a trinomial that's easy to factor. It's got an x in the front of each of the binomials because of the x squared. The two numbers that multiply to be 30 are 6 and 5 because they add to be 11. Over here, the two numbers that multiply to be 20 are 5 and 4. Because they add to be 9. So the LCD for this problem has 3 binomials. It's got an x plus 4, an x plus 5, and an x plus 6. So again, x plus 4, x plus 5, and an x plus 6. So this fraction has the x plus 5 and the x plus 6. So it is missing the x plus 4. So when I distribute that, I'll have an x squared and a 4x. So an x squared plus a 4x. I'm going to get a little bit more proper here, and so now that has the x plus 6, it has the x plus 5, and now because of what I just did, it has the x plus 4. This one's missing the x plus 6. The 5 is missing the x plus 6. In order to be sure I get this minus sign right here, I could either call it 5x plus 30, but if I do, then I have to change both of their signs because it's subtraction. So I'm going to add a negative 5 here, and I'm going to make that a negative 5x and a minus 30. So a negative 5x and a minus 30, and now this is a plus sign. And this now has, it had the x plus 5, it had the x plus 4, and now it has the x plus 6. So now I'm going to go ahead and combine the like terms here. It's the 4x and the minus 5x. So those two combine to be a minus x, but there's an x squared in the front, then a minus x, then a minus 30, over the x plus 6, the x plus 5, and the x plus 4. Well, here's the deal. I think I'm done. I'm all happy. But I notice that this trinomial might factor. The numerator might factor because the first terms will be x's, and the two numbers that multiply to be a negative 30 and add to be a -1 are a -6 and a +5. So that's the numerator. The denominator has an x plus 6 in it, an x plus 5 in it, and an x plus 4 in it. So son of a gun, if those x plus 5s can't be reduced, just like we did in the very start of all of this, so this has to be taken that final step so that all you have is the x minus 6 in the numerator and the x plus 6 and the x plus 4 in the denominator. Let's go ahead. I just am not going to show you how I factor these denominators, but in long part, it is take these two and find two numbers whose product is a -12 and adds to be 1, and break this out into two terms and factor it by groupings. But I happen to be able to guess and check these factorings, so I know this is going to need a 3y here and a y here. I'm going to put a +4 here and a -1 there, and that should be the factored form of that. Absolutely it is. This one, I'm going to put a 3y and a y, and I believe this one's going to require a +4 here and a -2 there to work out. So the LCD includes a 3y plus 4, it includes a y minus 1, and it includes a y minus 2. So this denominator's got the first two, but it's missing the y minus 2. So the 7 has got to be multiplied by the y minus 2. And when I do that, I'll get a 7y minus 14, and I have the LCD for that. That's all three binomials. This one is missing the y minus 1 right here. So this 9y plus 2 has to be multiplied by y minus 1. Remember, you're multiplying this by y minus 1 too. I'm just not writing it every time because it will cause me to have the LCD, all three things. When I FOIL this, that's what I've got to do, a binomial times a binomial. 9y times y is 9y squared. Then this 9y times a minus 1 is a minus 9y, and this is a positive 2y for a total of a minus 7y. And then this 2 times a minus 1 is a minus 2. And finally, I'm ready to add these two. So I'll bring down my 9y squared, but notice the 7y and the minus 7y will cancel out. And the minus 14 and the minus 2 combines to be a minus 16. Oh my. I'm not going to bother to copy down the LCD because I can see that that numerator will factor. It's a difference of squares. And a 3y will go in the front of each of these because the square root of 9 is 3. And a 4 will go in the back of each of these, a +4 and a -4. So finally, I'll put this over my LCD, which is 3y plus 4, y minus 1, and y minus 2. So I get to cancel out the 3y plus 4s, one on the top and one on the bottom. I'm not going to rewrite this. My answer is right here. It's the binomial upstairs and the two binomials downstairs. Is the simplified form of adding these algebraic expressions together. I think I'm going to stop here, pause here, and begin another short segment dealing with a few applications.